Hi YouTube, my name's Jeff and I'm the VogMan. A few weeks ago now I promised you an electric foundry build, and here it is. Grade 28 insulating fire bricks, homemade Kanthal coils, push button temperature control, nice big well insulated lid, plenty of room for my A6 crucible, and I could squeeze an A7 in there as well. But hang on a minute, that's a bit of a tight squeeze. How do I get the crucible out? There's no room for crucible tongs. A simple electric hoist. Nice, easy and safe. Not bad for home construction and fairly basic tools. I'm going to be talking you through how I built this step by step. From there you can build one yourself, or maybe incorporate a few of the ideas in your own design. This project is more involved than I expected, so to show you everything I need to get across, I needed to split the video into parts. Sorry if this bothers you, but I don't want to skimp on any of the important stuff. Right, so why an electric foundry? Well, for me I have to say it's all about convenience. I can work indoors and plan my time with much more accuracy. It's clean and it's quiet, but it's not fast. If you want fast, stick with oil, gas or solid fuel. But if you're the patient sort, probably the biggest plus of an electric foundry is efficiency. You can dial in an exact temperature and get there without wasted energy. But it can take a few hours. When it comes to the design, I want to say a big thanks to Tao. This amazing young man was amongst the first to share an electric foundry build. I would have built Tao's exact design if it hadn't been too small for my needs, but it was very inspirational. Tao made excellent use of limited resources, constructing walls from just 4 grade 24 fire bricks, plus a few cut-offs. Unfortunately, there was no way I could fit my A6 crucible inside this, so I needed to come up with something different. And this is it. It uses a lot more blocks, but it does almost double the foundry capacity. And importantly, laying the bricks on their side rather than their edge maximises their insulation capabilities. I purchased 30 grade 28 fire bricks and cut 24 using an electric miter saw and a water soaking technique, which I've already shared with you in another video. If you're going to do the same thing, just remember not to use your best blade. Cutting in this fashion gave me a lot of offcuts, which I was able to make very good use of, as you'll see later on. A 30-degree cut on each end should create a perfect hexagon, which when stacked 4 rows high should look like this. This is an indoor project and a stationary one, so having cut my blocks I set about making a sturdy wooden table. It's fixed to the wall and is solid enough to take even my hefty weight. It's not strictly necessary to build a table. You might build straight off the floor, but it makes sense when dealing with dangerous temperatures to work as comfortably as possible. So whilst this table is quite short, it's custom made to be a comfortable working height for me. Loosely arranging the bricks on the table inspired me to make the first use of my offcuts, as I decided to double the depth of my base. I drew a pencil line around the shape and arranged some of the offcuts in a similar pattern. There's a lot of air gaps, but air is an excellent insulator. The gaps are quite small and overall there's plenty of strength to support the upper layers. I decided to bond these in place using ordinary expanding glue. Now this wouldn't survive any moderate heat, but this is very low down in the foundry and so far it's proven to stay perfectly cool down there, and I'm very pleased with the result. When I purchased the bricks I also bought some appropriate fire brick mortar, and this is a must when applying the next layer of bricks, the actual base of the foundry. This is applied very thin to both surfaces and can literally be scraped on and off. I later found that the best technique when mortaring these bricks is to make a very runny coat by simply adding water. This can then be painted on with a brush. The absorbent surface of the bricks laps this up, and you may even want to immediately add a second coat, but do keep it thin. Mortar can then be scraped on and off. The surfaces are pushed and mushed together to ensure a good fit. Within minutes this is virtually bonded. Once this layer was finished, I left it 24 hours to go off. The next day I wanted to ensure the base was very flat, and my hands told me there were imperfections. I tackled these with a combination of a rasp and some coarse sandpaper stuck to a board. A large flat board indicates there's no rattles and everything is nice, flat and true. There's a fair bit of welding in this project, and I'm no welder. I'm still learning, and both my equipment and my welding talent are on the cheap side. But it is possible, even for me, so don't be afraid to have a go if you've never done this before. I took some angle iron and ran this around the perimeter. With a marker pen and a straight edge, I was able to mark out the angles, and cutting these was easy enough with an angle grinder and a thin blade. A chop saw or hacksaw would do the same job. Using a wooden block to protect the soft bricks and a couple of large clamps, I was able to secure the angle iron in place whilst I welded it. I then flattened off the welds with my grinder. As this metal frame will hold and support all the bricks above, it's necessary to extend it a little towards the middle. I cut these sections of straight bar at 60-degree angles and welded these in place. Now I rushed this a little and I paid the price later, so I'd encourage you to take your time and be more precise here than I was. With these welded and grinded back, I added another row of angle iron in the same way. This is welded securely to the frame below, adding considerable strength. My thoughts originally were to have this frame rise and lower directly onto the blocks, but I changed my mind, as you'll see in a moment. I then filled in the centre void with 2 more bricks, making sure everything was nice and flat. It was at this point that I noticed I was already starting to lose some of the corners on these very soft bricks. This meant that the frame onto the brick plan was going to need to change. So I made this, a slightly smaller hexagon from slightly smaller angle iron. It fits nicely, but not too loosely, inside the larger frame, and its purpose is to prevent further chipping. Initially, this frame was obviously smaller than the perimeter of the base, so with it centralised, I was able to use a marker pen and draw around the inside. This showed me how much I needed to cut away. It's only a small slice that needs taking off, and it can be done with hand tools, a saw, a rasp, or even just sandpaper. I actually used a router with an old straight cutting bit, though a mask is essential there as there's a lot of dust. With the edges cut to size, the top is marked with a sharp blade. This marked area needs to be removed just a little deeper than the thickness of the angle iron. Again, I used the router for this job. The frame can now be mortared onto the bricks, pushed on firmly and made flush to the surface. Take time to fill in all the gaps. Whilst this was drying off for 24 hours, I returned my attention to the larger frame. I knew I needed some brackets adding, and I made these from some more angle iron. I marked, drilled and cut these, rounding the edges with my angle grinder. I needed 8 in total, with a 10mm hole in each. 4 of these are welded to the frame, each in the centre of its side. To make life easier, I numbered the sides, and you'll see these markings throughout the video. I also made 8 larger brackets, and I knew these would be separated by 2 lengths of inch box steel, though I was uncertain about the size at this point. So I made use of some scraps to help me position these, and I welded them to the frame. I gave the frame a quick clean to remove all the welding splatter, and I gave everything a coat of rust killer. The next day, returning to the base, the large frame lowers nicely over the metal rimmed bottom. Unfortunately, thanks to welding, the frame has developed a slight warp. The weight of the bricks will easily cope with this, but the frame needs to be held down with straps for the time being. But before that, the first row of bricks needs attention. The shape of the frame needs to be recessed in each brick. As I wasn't very careful with my framework, I needed to make individual patterns for each brick. This is easy enough with charcoal and paper. With a router and a straight cutting bit, it's simple to recess the depth of the outer frame, though this could also be done with a rasp or a file. Returning to the charcoal patterns, each is placed on the block and marked with a sharp blade. It's worth rotating the pattern 180 degrees, as it is in fact a mirror image of the frame. With this done, I glued some coarse sandpaper to a length of flat bar and used this to sand away the depth of each recess. Whilst we're working on the blocks, it's time to reassess the location of the coils, and coils are a big topic. So let's digress for a while and talk about resistance coils. This is a resistance coil I made myself. It's simply a length of wire wrapped in tight circles to shorten its overall length. The length, type and thickness of the wire determine how much electrical resistance the wire carries. Generally, the thinner or longer the wire is, the higher its resistance. Similarly, the shorter and thicker the wire is, the lower its resistance. When electrical resistance occurs within a wire, heat is generated. If the wire is capable of handling heat for prolonged periods and the conditions are just right, it's possible to make the wire glow red hot. And that's what a resistance heating coil element is. The power of the coil is measured in watts, with 1000 watts being 1 kilowatt. Now here's a nichrome coil I bought off the internet, and here's one I made myself. Mine is made of thicker and many would argue superior Kanthal wire. It's much taller and most importantly it's made to measure using a simple jig that I've already shared with you. And that's the advantage of making your own coils. You get exactly what you want, but to do this you do need to understand the electrical requirements and restrictions involved. Let's start with voltage. This is likely to be the mains voltage in your part of the world. Here in the UK, for example, mains voltage is 230 volts. In the US and Canada, I believe it's 120. Whatever your region, you need to know this if you're going to make a coil. Next, and to me most crucial, is current. Remember, it's current and not voltage that kills you, so getting this right is critical. You must decide what sort of current levels you want your coils to draw. It's very important to determine the maximum output of your outlet. Again, using the UK as an example, the average electrical outlet has a fused output of 13 amps. As my Foundry is going to be plugged in a UK outlet, I obviously needed a coil that would draw less than 13 amps. Dropping to 12 is still a little close to the mark for me, so I chose to draw only 10 amps of power, staying 3 amps below the threshold, but that's a personal choice. The closer I get to 13, the more likely I am to blow fuses and have electrical failures. The further I go from 13, the weaker my Foundry will be, because it's current that drives your Foundry. So you must identify the current output of your outlet, guys, and then drop it down 2 or 3 amps for safety. With that done, you can do a little maths and see how much power you might get. Potentially, at 230 volts and 10 amps, I could achieve 2300 watts or 2.3 kilowatts of power, which isn't bad for a domestic appliance. Don't be tempted to use more than one outlet to drive your Foundry. This is a bad idea. Unless you have a dedicated high current line installed, it's quite possible that you could exceed the power rating of the mains cable that supplies your outlets. Dividing your voltage by the current will calculate the resistance required by your coil. In this case, 23 ohms. Thicker wire generally has lower resistance than thinner wire, but thicker wire is generally more durable in a Foundry environment. So buy thick wire if you can, but keep in mind the resistance you're trying to achieve. Resistance wire should state the resistance rating per unit length. In this case, 1.73 ohms per meter. As the rate per length gets lower, the coil must get longer, and if the coil gets too long, it won't fit in your Foundry. So keep this in mind. I was able to calculate that I needed approximately 13 meters of wire to achieve my required resistance of 23 ohms. In my coil making jig video, I mentioned that I've got a free coil calculating page on my website, and that can help you determine the exact length of the coil you need. I also give examples of the necessary maths and the formulas for those who like to do a bit of number crunching themselves. Rather than one coil of 13 meters, I decided to make 2 coils of 6.5 meters each that would be joined together to make a single coil. The coils must be stretched before use. This is easily achieved by gripping each end and gently pulling until the desired length is achieved. Generally, it's advised not to stretch them more than 3 times the original length. The coils also need tails. These are easily made by unravelling a short length at each end and twisting in 2 or more lengths of wire. If you're careful, you can do this with a drill, but don't over tighten or over twist, as the tails will snap. Thickening the tails in this manner creates a better fixing point. It also reduces the resistance of the tails and thereby helps them to stay cooler than the coil itself. It's best at this stage to leave the tails fairly long, as the excess can be cut away later. And that finishes off coils and brings us back to recessing. And a common problem in electric foundries is creep, a condition caused by repeated heating and cooling, where the coils sag from their grooves. Thinking on this, I decided to create circular grooves, with an opening large enough to let the heat out, but not the coils. I achieved this for the most part with my router. However, it can be done by hand with a round file. The bottom row of blocks requires an upper groove, the top row requires a bottom groove, and the centre requires both. The blocks in position 2 don't require a full groove. This is where the coils will start and finish, so leave an inch or so of this uncut. This will prevent the coil ends coming together and shorting out. Before the blocks are fitted, it's a good opportunity to install some small bolts as connection points for the electrical contacts. I did a simple experiment with car body filler, 2-part epoxy adhesive and this metal putty stuff to see which responded best to heat. I don't expect they'll ever get this hot, but the winner by far was this metal putty. This is the bottom position 2 block. A hole the same diameter of the bolt is drilled to a depth of maybe 3/4 of an inch. The dust and debris is cleared from the hole and then the putty is mixed. Very little putty is needed. This is pushed into the hole, but you shouldn't try filling it completely. Leave some room for the bolt. As the bolt is pushed in, it's turned so that the putty grips the thread. Any excess putty can be firmed down or removed. Then it's just a matter of waiting 10 minutes. 3 of these bolts are needed, 2 in the middle block and 1 in the bottom block. A small channel needs to be made for the tails, and these can be carved with a saw blade on the top of the blocks only. Don't cut away too much, keep things nice and tight. A hole is drilled all the way through the bottom block to accommodate the thermocouple, which is a thermometer. This comes with a bolt fitting and it just happens to be an 8mm thread. So I decided to carve away an opening to accept an 8mm nut, which is very easy in these nice soft bricks. The metal putty is used to bond the nut in place, and a piece of threaded bar is used to hold things in place whilst the fitting dries. This also prevents the thread from getting clogged with putty. Once dried, the threaded bar can be unscrewed and the thermocouple can be test fitted. You can see it's just shy of the inner wall of the foundry, and this will be fine. As I keep saying to my wife, it's the tip that's the most sensitive part. I've also enlarged the hole around it a little. And here are the bottom and middle blocks with their connections fitted. One last thing on the subject of shaping these bricks. They can be quite forgiving. Here I ran a groove on the wrong side of the block, but shaping a slice of scrap material was easy and it bonded a treat with the mortar, so you can patch the odd error if you have to. Returning to the base now, I smoothed down some thin polythene and taped this in place. I want to bond the bottom row within the frame, but I don't want the mortar to stick to the base, so this thin bag will form a protective layer. The frame is placed over this and the wobble is still evident and needs sorting. A few screws are partially screwed into the table. Ordinary cable ties are then looped around these and through the brackets. When these are pulled tight, the wobble in the frame is removed. Once the weight of the bricks is present, this shouldn't be an issue again. I dry fitted the bottom row to ensure the grooves lined up nicely with the frame. I then placed a thin coat of mortar on the bottom of each block and also made sure there was some mortar in every groove. Don't overfill the grooves, but do leave enough room for the mortar to ooze out and fill all those voids. Take your time with this row and get it right. It needs to be firm, flat and level to support everything that follows. It's probably best to give everything 24 hours before moving on to the next row. It's here that the first of the coils needs to be fitted. Now this can be a little bit fiddly, but with patience it can be done. For now, leave the tail sticking out of the channels. With this second row, personally I bonded each of the ends of these blocks to each other with mortar, but I did not bond the bottoms. This is important as it may be necessary to remove the coils in the future, so we will need to be able to raise the blocks. In truth, I'm not convinced that mortar is needed from this stage onwards. If your cuts are nice and true and there's no discernible corner gaps, it's probably best just to dry fit everything. You'll see why in a moment. With the second row fitted, the second coil can be inserted as before. The top row can be added, and again, no mortar between the rows. Once the top row is fitted, if you used mortar, leave things for a good week, just for good measure. The tails of the coils can now be connected to the studs. This is a little fiddly to show in situ, as the gap is quite narrow, but here are the bricks as they were on the bench. Looking at the bottom block, imagine there's two tails sticking out. These obviously connected to the bottom coil. The right tail is connected to the bottom stud. It's looped around, any excess is trimmed away, and the nut is tightened home. But don't over tighten, it's not necessary. Looking at the studs on the top block now, these are obviously connected to the top coil. Again, the right hand tail is connected to the stud below it. The two remaining left tails are connected to one another on the remaining stud. This in effect joins the two coils together, making one long coil. Hopefully you can see these connections in place here. Personally, I slid some high temperature sleeving over the tails first. This insulates the wire and helps retain the heat. It's cheap enough and a worthwhile time investment. Using a multimeter at this point, I'm able to take a reading across the coils at roughly 25 ohms. Now this is a little more than I wanted, so I clearly wasn't very accurate with my coil lengths, but I'll live with it for now. It should give me about 2.1 kilowatts, and I'm happy with that. With the main body of the brickwork finished, it's time to add yet another frame, made from the same angle line as before. Onto this I welded the 4 remaining brackets that I made earlier, and these correspond with the brackets below. Some 10mm threaded bar is cut to length, and this connects the top and the bottom brackets with a couple of nuts. Hand tight plus quarter turn with the spanner is tight enough. Over tightening will only crush and crack the bricks. As this video is already getting a little long, I think we'll call that the end of part 1. But don't worry, the rest's coming very soon. Just a couple of days should see it finished, so please look out for it. In the meantime, please look out for my other videos on my YouTube channel. Please subscribe if you haven't already, and send me your comments and your questions. So that's it for now guys, thanks for watching.